Hey Algebra 1, and thanks for tuning in. This is your midterm review for your spring semester midterms. Let's go and get started. The first one, you're going to be having to put the a to the negative first power on the bottom because we only want positive exponents. So we'll get 4a to the second power over a to the first, and then we can simplify our exponents by subtracting. So my final answer would just be 4a. For number 2, I'm going to add my exponents. I'm going to get m to the fifth. Number 3, anytime I have an exponent outside parentheses, remember that gets distributed to everything inside the parentheses. So I'm going to have 2 to the third times x to the ninth, because I multiply those two exponents together. And eventually, when I do 2 to the third, I'm going to get 8 x to the ninth. For number 4, anytime I distribute, again, a number from the outside of the parentheses to the inside, that would be -3 times 0, which is still going to give you m to the 0, which would then give you just a number equal to 1. For number 5, remember we're going to combine like terms, so I'm just going to start with my first thing. 2 times 2 is 4. The next thing I see is a y. So I could do y to the third and another y to the third. That can be y to the sixth. And then I have x to the second that's left. I could keep it like this. If you also switched around your y's and x's, that is fine as well. For number 6, I went ahead and looked at my 3's. So 3 times 3, that's going to give me 9. And I'm going to make a top and bottom because I see some negative numbers here. X. I have a regular x, so I'm just going to keep that up at the top. Y to the negative third, that's going to go to the bottom. X to the 0 just cancels out to be a 1. Y to the negative fourth, that also goes to the bottom to be a positive 4. X to the negative third, that will go to the bottom to make it a positive 3. And then y to the third will stay on top. Now I'm ready to simplify. I notice that I have a y to the third and a y to the third at the top and bottom, so those will be able to actually cancel out. Now I'm just left with 9x over y to the fourth x to the third. Remember, x by itself has an automatic exponent of 1, so if I use that information, I can subtract and I would get x to the negative second with the 1 minus 3, but since it's negative, I want to put it at the bottom again, so my answer would be 9 over x to the second times y to the fourth. Sorry about that interruption. So yes, my answer is 9 over x to the second times y to the fourth. For number 7, remember everything will get distributed in number 7. So what I went ahead and did, because I'm distributing a negative, most everything is going to move down to the bottom. For instance, 2 to the negative 2, I'm going to write it on the bottom to make it positive. X to the negative 2, write it on the bottom. But when I have y to the negative 1 times y to the negative 2, that's going to give me y to the positive 2. Next I'll have y to the negative 2, that'll go on the bottom. And then x to the negative 4, that would actually change to x to the positive 8. Again, noticing that I can simplify my y to the 2's. And then I would have left x to the 8th over 2 squared, which is 4, times x squared. I'm going to go ahead and subtract these two exponents right here. So I'll have x to the 6th over 4 for number 7. For number 8, I'm going to go ahead and again use my top and bottom method that I've been using. B to the second is just going to stay on the top. A to the negative fourth times 4, that's a to the negative 16th. A to the fourth will still stay on the top. Oops. Backing up. A to the negative 16th was on the top, but to move it down to the bottom would change it to a positive. A to the fourth is still going to stay on the top, and then I have b to the negative second, which I'll put on the bottom to make it positive. Now I'm ready to subtract. Again, I notice that I have b to the second and b to the second, so those can cancel out. Now I have a to the fourth over a to the 16th. When I subtract 4 minus 16, I get negative 12. but to make it positive, I'm going to put it down at the bottom. So my answer for number 8 would be 1 over a to the positive 12. For number 9, I'm going to just simplify the r's. 3 minus 4 is going to give me negative 1, and put that on the bottom to make it a positive 1. So for number 9, I'm going to have 1 over 4r. Number 10, I'm going to move the k to the negative third power down to the bottom. So I'm going to have 3 over k to the second times k to the third, which would be 3 over k to the fifth. Number 11, again, just moving the things that have negative exponents. The 4 is going to stay up at the top. X to the negative second, I'm going to put that down at the bottom. Cross off as I go. Y to the negative second, put that at the bottom. This 2 can stay down at the bottom because it doesn't have any negative exponents. So can the x to the fourth. But the y to the second, negative second, is going to go up to the top to make it positive. Once I've moved everything, I'm ready to simplify. These y's can be canceled out because they have the same exponent, and when you subtract them, they just get 0. 4 and 2 can be simplified. The 4 will change to a 2, and the 2 would just change to a 1. So I'm going to put the 1 there just for now so you can see it. And then I have x to the second and x to the fourth. Together they will make x to the sixth. So when I'm ready for my final answer, I'm going to have 2 over x to the sixth power. For number 12, again, moving anything that needs to be moved. And the only thing I see that needs to be moved is the y to the negative first power. So I'm going to go move that up to the top. So now that I have everything moved where it needs to be to make positive exponents, I'm going to go ahead and simplify any common bases. I notice x to the fourth and x to the first down here can be subtracted. So I'm going to get x to the third. The 3 still stays up at the top because it doesn't have any negative exponents. And then the y's can be added together as well to make y to the third. So my answer for number 12 will be 3x to the third times y to the third. 13, again, we're still moving some negatives. The only negative I'm going to move is v to the negative first power, and that's going to go right up at the top. So I'll have 3v to the second, 2v to the third, v to the first, over 4u to the fourth. I'm going to go ahead and simplify all the v's at the top and the 3 and the 2. 3 times 2 gives me 6. And then I have v to the second, v to the third, and v to the first. That's 2, 5, and 6. So v to the sixth, and then over 4u to the fourth. I can keep simplifying here because 6 and 4 have something in common. They both can be decreased or simplified by 2. So I'm actually going to rewrite my answer as 3v to the sixth over 2u to the fourth. So there's my answer for number 13. 14, again, just looking for common things that I can put together. 2y to the second, I'm going to leave that one alone because there are some things I can combine here at the bottom. 4 times 3 is going to give me 12. And then I can combine my exponents. X to the fourth times x would be x to the fifth. And then I have a y to the fourth by itself. Again, we can subtract and simplify the 2 twelfths. 2 twelfths is going to reduce to 1 over 6. X to the fifth is still going to stay at the bottom because there is no other x we can combine it with. And then we have this y to the second and over y to the fourth. I'm going to subtract those, and I would get y to the negative second, but since it's negative, I'm going to bring it down to the bottom to make it positive. So my answer for number 14 is 1 over 6x to the fifth times y to the second. 15, again, we're just trying to simplify as much as we can here. What I would go ahead and do is notice that this section is having a 0 distributed to it, and that's just going to cancel it out because the whole thing's going to be equal to 1. And the same thing with this x to the 0. So really, all that you have is 2xy to the fourth over 2y. Again, these twos can be simplified because they can be simplified by each other. So now I just have x, y to the fourth over y. I'm going to subtract my y's. So I'm going to get x, y to the third. Number 16, again, we're distributing everything, so what I would recommend is just starting with a big fraction and then working there. So we're going to distribute. I'm going to have 2 to the second power, still on the top, m to the second power, and then n has a negative, and negative 2 times 2 is negative 4, so it's n to the positive 4 on the bottom. And then up at the top I still have 2m, and then again the n is a negative 4, so that's going to go on the bottom as well, so n to the positive 4. Everything that I'm seeing here, though, on the bottom, is getting distributed a negative 2, but I'm only going to move the m to the top. M to the fourth times negative 2 is negative 8, and put it to the top I get positive 8. The reason I'm not going to move this n, though, is because 0 times negative 2 is still 0, and that's just going to cancel out to give me a 1. So now I'm ready to simplify. I know 2 times 2 is 4, and 4 times 2 is 8. So that'll be the new number on the top. And then I have a lot of m's up here. I have m to the second, plus another one, that's 3, plus another 8, that's 11. And then I have n to the fourth over times n to the fourth, that's going to give me n to the 8th. So my answer for 16 would be 8m to the 11th over n to the 8th. The next part, we're just simplifying each expression and writing our answer in standard form. So this is probably the most recent thing that we've talked about. For number 17, remember we are distributing the negative, so everything in the second part would be going to its opposite. So I'm going to have 5k to the third. Everything in that first column is going to stay the same, but then everything else is going to change to its opposite. So minus 8k, and plus 1, and plus 2k to the third. Now I'm ready to combine like terms. 5k to the third and 2k to the third gives me 7k to the third. (6k minus 8k gives me negative 2k. And then negative 4 and positive 1 gives me a negative 3. Number 18 was kind of simple because nothing changed. So what I did is I basically just combined like terms from here. P to the third and negative 7p to the third is negative 6p to the third. Next I have 4p to the second and 2p to the second. That's going to give me positive 6p to the second. And then the last thing I'm going to put together is 8p and 5p to give me 13p. So that'll be plus 13p. For number 19, again, combining like terms. So what I'm going to get, nothing is going to change in either the first or the second. So what my final answer would be 4x to the fourth. And I just said plus minus, but you can do minus negative 2x squared plus 7x and plus 4. At number 20, everything in the second paragraph or second parentheses would change to its negative. So that'd be a negative 1, a positive 3n cubed, and a negative 2n. And then I'd be ready to combine like terms. So my answer for number 20 would be 2n cubed minus 9n plus 5. For number 21, you're just finding the product. Remember, the best thing to use here would be our FOIL method. So for 21, when we FOIL, we get 36b squared minus 36b plus 18b minus 18, and then we're just going to combine these two inner terms, and our final answer would be 36b squared minus 18b minus 18. Again, 22 we're foiling, so after we FOIL, we get 16x squared minus 40x minus 14x and plus 35, and then we can combine my two inner terms here again to get 16x squared minus 54x plus 35. For 23, again foiling here, we get 1/3 b squared minus 3b plus 1/12 b minus 3/4. And then we're going to combine the negative 3b and the positive 1/12 b to get 1/3 b squared minus 2 and 11/12 b minus 3/4. 24, again we're foiling here. After we foil, we'll get 12mn squared minus 14mn minus 18mn plus 6n squared. And then let's combine the m and the n in the middle so we can get 12m squared minus 22mn plus 6n squared. And then our last two, again 25, it would be best to maybe write it as two separate binomials first. Once you write it as 7m plus 4 times 7m plus 4, then you're ready to foil. Foiling, we'll get this. And then once we're ready to combine like terms, we'll get 49m squared plus 56m plus 16. The last one, number 26, you can actually use your difference of a square to help hint yourself. So that would be basically meaning a squared times b squared and keep it as a minus. So you should just have gotten 25 r squared minus 1. That is going to be the conclusion of our midterm review. Thanks so much for tuning in, and good luck on your midterm.